So are you able to see the screen?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay. Okay. Thank you. Okay. So now I welcome you to the live session for the course Basics of Finite Element Analysis Part 2. So this is the fifth week of the live sessions we are seeing into. The course instructor, as you might know already, is Professor Dr. Nachiketa Tiwari from IIT Kanpur. And once again, introducing myself, I am Vikram Balaji, a research scholar from the Department of Mechanical Engineering at IIT Madras. So this is, as I told, is a week 5 of the live session. Totally, there are 8 weeks, 8 live sessions. So this is the fifth one. So a small recap of the week 5 contents, lecture contents. So if you have observed the lecture contents of the week 5, so there were broadly 4 topics. First one is a small introduction to the 2D finite element problems with a single variable. So we might have introduced a model equation for the two-dimensional FEA problem with single variable. And next we saw about how to discretize the 2D domain, and we also saw about the weak formulation of the model equation. So weak formulation in the sense we are doing this to get the equations at the element level. So this is what is the third one. This is elemental level equations. And then we saw certain interpolation function, basically for certain type of elements. So in this case it's a linear triangular element. So we might have seen about various types of elements and the type of the function, linear function, bilinear function and all. And in one particular case we saw how to get the interpolation function for the linear triangular elements. So these are the contents of the week 5 lecture. So with respect to this, we are going to solve some sample assignment questions. So like as usual, it will be a combination of both a objective and the subjective. So now we'll look into the questions one by one. Okay. So this is the first assignment question, sample assignment question. The type of error that does not occur in a one-dimensional FEA but could be associated with a 2D finite element problem. So there are 4 options provided. The first one is the approximation error, B is the computational error, C is the computational domain error, option D refers to none of the above. So what do you think could be the answer to this question? So the type
Sir,
of error,
domain error, sir.
yes,
Domain error.
okay, okay, domain error. Okay, so let us see the answer. Yes, answer is the computational domain error. So in case of a one-dimensional finite element problem, our domain itself is of a one dimension. So let us say it's a x-axis. Our element is nothing but a domain is nothing but maybe some one-dimensional element of length L, which is divided into further subdivided into further number of elements. So if the domain length is ranges from 0 to L, let us say, so if it is divided into maybe 4 or 5 parts, then accordingly we'll have some element length associated with it. So in this case, if you see, the entire domain is covered by the elements. So there is no portion of the domain that is not covered by any element that is left uncovered, I can say. So 1 2 3 4 5 5 elements, and if I combine all the 5 elements, I get the domain 100%. So there is no domain error associated with the one dimension. But let us say we have a domain like this in the two dimension, like this. So let us say this is x and this is y. So if I now try to discretize the domain, so using rectangular elements, or I can use triangular elements also. So like this we are doing. So inside also I am going to discretize. So something like this I am getting. So, but what we are observing here is there is some portion of the domain that is not covered by any element. So you can say the shaded portion. So this shaded portion in the green color, as you can see, it is not covered. All this domain is it can be of any random shape. It not necessarily that is perfectly circular or perfectly rectangular or any shape. So it is a some random shape, and we are trying to discretize the domain using some rectangular two-dimensional elements. So we see that there are some portion which is not covered by the elements. So these correspond to the computational domain error, because our domain is not 100% discretized. There is some maybe some 1% of the area of the domain which is left undiscretized. So because of this, there could arise something called as computational domain error. So when you look at the mesh, it will be like a discontinuous, it will be like a piecewise circle, not a continuous circle. So this is one question. So let us go to the second question. So during discretization of the 2D FEA problems, the smaller element size is used in the areas of, we have four options. So areas of lower gradient, or areas of higher gradient, or areas of zero gradient, or none of the above. So what could be the answer for this question? So smaller element size. So gradient in the sense, so suppose you have a variable or a parameter, say you want to measure the stress at a point in a at any point inside the domain. So when there is a lower gradient, means the change in stress from one point to the other is very smooth. So that is a lower gradient. And when the variation is very instantaneous, you can say that there is a higher gradient. So in such areas, what type of elements do we generally prefer is the question. So where there is a sudden change in stress, or where there is a very gradual change in stress, so that you can say that it's a lower gradient, higher gradient, or there is some cases where there is zero gradient. So
Higher
yes,
gradient.
higher gradient. Okay.
Like,
Lower.
Okay.
Okay.
Yes. So let us see the answer. Yes, you are right. Answer is a higher gradient. So generally, so if we have some cases where you have a domain like this and you are applying a point load. So theoretically speaking, you know that stress is defined at a point as the force per unit area. So in that case, if you see that if you take it as a point, you can say that if you try to theoretically speaking, the stress might be infinite at that one particular point, because it's a point load. But in reality, any load, it cannot be a point load as such, because there will be some amount of area associated with it. Even though it is very small, it theoretically it will not be a point. So you can say that here the stresses will be high, but as you go towards the, at the same time, if you go towards the center here, the stresses will be low. So you can say that we have to use very small elements in this region, and as we go in inward and inward, we can use the larger elements. So at places of higher gradient, we need to use smaller element size. So this is the answer. So let us go to the next question. Again, this is also related to discretization. So during discretization of 2D finite element problems, so there is a type of elements called transition elements. So transition elements are used mainly to connect two elements of, could be any option. So option A is different order. So two different elements of two different order. So option B is different sizes of elements. Option C is different shape of the element. Option D is all of the above.
All the above, sir.
Okay, this is one option, all the above. So first of all, we need to know what is a transition element for that. So one is option. So any other guesses? Do you think, or is this answer okay?
Sir, what we seen in the lectures are given taken two rectangle, maybe four noded one, another one is
Yes.
maybe six noded,
Yes.
maybe six or eight noded.
Yes.
maybe they were connected by using again same rectangle connecting
Yes.
rectangle, and one more thing is triangle, like triangle,
Triangular, linear triangular elements you might have
linear
used.
triangular element. That
Yes.
is what we know. I hope
Yes.
option B. Then I don't know.
Okay. Okay, this is fine. So you have seen two cases. One case is we have used a rectangle where there is a lower, you can say it's a two noded in one side and maybe three noded or four noded in the opposite side. So that is one type of connection. Another connection you mentioned is our linear triangular element. So do you think both the cases are transition element, or only one of them is using a transition element? Which do you think both the definition are transition elements, or only the first option or only the second option? So any idea about this?
There may be two, whatever given, there may be two. First one, they taken the rectangle with
Yes.
two, two noded, but on the other side you have
It is
three
a,
noded.
yes, correct.
So
Okay.
two noded
I-
from left side, and right side we have six nodes, maybe three noded in other side.
yes. Okay.
That I don't know, sir.
Okay, no problem. So we'll just look into it. So I'll just exactly revisit the two cases. So let us say that you are having a element like this where you have only nodes on the end points. So this is some lower order thing, and then we have something like this. So it's a 8 noded. So in between you can say that you are going to connect through some kind of element which will have a only two nodes are here, but it will have three nodes here. So this is one kind of connection. Another connection is, you say you have like this. So what you are going to do is you are going to connect using triangular elements. So three triangles. Okay, but actually by definition if you see, only this is called as a transition element. Here also there is some transition involved, but you can see that they are regular type of elements. They are not any different transition type of element. They are only a regular triangular elements, you can say. So to differentiate, I'll put TR, TR, TR. So these are triangular elements. So actually answer is A. So one might be confused because you see that here it is connecting using different shape also is there, different size also is there, but by definition it is only the order of the element that connects from one lower order to higher order or higher order to lower order, that is only is defined as a transition element. So here if you see, although there is some transition is there, but transition is done using the regular element, not a different transition type of element. So is there any doubt in what I explained?
No problem, sir.
Yes. So both the cases we saw the cases, but the first case is only related to the transition element. The second case is the linear triangular element like this. Okay. So we will go to the next question. So one more question regarding the discretization. So again, during the discretization of the 2D finite element problems, the transition from areas of lower element density to higher density must be dash, and transition elements should be placed at areas dash critical regions. So we have two options corresponding to each fill in the blank. So first blank is either it can be a instantaneous, that is a transition from lower density element to higher density elements. It should be either instantaneous or it should be gradual, and transition elements should be placed at areas close to the critical region or away from the critical region. So we have two options, four options, so two options for each fill in the blank. So can you guess what
The
could be the answer?
gradual that I know, the
Yes.
gradual and close to the
Okay, so
critical region might.
critical. Okay. Okay, transition elements we just saw. So it means that we have a lower order element and higher order element, means to connect them we are using some kind of a transition element. So that could be two noded in the left hand side and three noded in the right hand side. So this is one thing. So in general, the answer, we'll just look at the answer. So answer is actually C. So which means the first option what you are told is right. The transition from lower element density to higher element density must be gradual. There is no doubt in that. But transition elements, what is the problem is, so suppose we are using a higher order element at the critical region, let us say. So critical region, your element size should be low, but at the same time your order of the element also, if it requires, it can be high. So this is one thing. But this transition, what happens is it should be far away, because when you are doing the transition, there is a stress variation due to the transition we are using, because here is a higher order element, here is a lower order element. So because of this variation, there is a variation in the stress field also. So this stress variation should be a little away from the critical area, because already in critical area you see the gradient is already high. If the gradient is already high, this variation also will affect the gradient. So what we are trying to do is, this stress variation we are trying to shift as away as possible from the critical area. So what we see is, more amount of higher order element we are going to place near the critical area, and far away only we are going to place the transition to the lower. So this again, this should be gradual. The change should be gradual and it should be away. So if gradual and away means, option is answer C. So the first option was right. The second option, always remember that the transition should be away. So any doubt?
No problem, sir.
Yes,
Okay,
okay. Yeah. So please remember this, and this is regarding the discretization. Now let us move away from discretization and we look into the 2D FE problems little. Okay. So as you might have already seen in lecture, this is a model equation. So what equation which I have shown here, it is called as model equation. So this model equation is nothing but, it's a two-dimensional finite element equation with one variable. So what is that one variable? That one variable is u. U is a dependent variable. Why it is two dimensional is, there are two independent variables, x and y. These are independent. Okay. So this is the equation, model equation. So you might know what is a Poisson's equation also, you might have seen. So for this equation to represent Poisson's equation, which of the following conditions need to be true? First option is a11 is equal to a22. Second option is a12 and a21 should be 0. Third option is a00 also 0. T is also, yes, yes, okay. So we'll see the answer. I think this is a very straightforward question. Yes, you are right. Answer is D. So we'll just see what if it actually means. So a11 and a12, let us say it is equal to a, means my equation is going to become dou by dou x of this a dou u by dou x, and this a12, if it is 0, it's going to vanish. So this part will not come. Then again here also a21 is going to vanish because it is 0. So it will become minus dou by dou y of dou u by dou y. So this a22 will be a, and this will also vanish because a00 is a, minus f is equal to 0. So this will mean that, so dou by dou x of a dou y by dou x and dou by dou y of a dou u by dou y. Okay. So this is, you can say, it's a Poisson's equation. So Poisson equation is nothing but, so minus, so you can say 1 minute. So I'll just erase this. Yes. So if I do this, if I want to express it in terms of okay, sorry, not laser, I'll take the pen. Minus, so you can say that it is of this form. again you can say so okay. So this is a Poisson's equation. Okay, sorry. So we can say that into this, for this equation to satisfy this case, all should be satisfied, which means that my a11 and a22 should be equal. So then you have a in both these things. So it will be equal to a, and this a12 and a21 should be 0. So then I'll have dou by dou x and dou by dou u by dou x in the one term, and dou by and dou u by dou y in another term. So if this is put together, we can say that it's the minus this operator. This operator is called as gradient operator. So gradient operator, you can say, is nothing but dou by dou x I cap plus dou by dou y j cap. So which means my del u is going to be dou u by dou x I cap plus dou u by dou y j cap. So if I multiply by a, so this is going to be a, and this is also going to be a. So if I dot product with this del, so which means that I am going to just combine this I part. So this means dou by dou x of a dou u by dou x, and this will be plus dou by dou y of a dou u by dou y. So both I'll have minus in the end because there's a minus. So this part is nothing but this. So this is the Poisson's equation, and we can say that Poisson's equation is a particular is a one particular subset of the model equation. Okay. So next question. So the theorem used for the development of boundary terms during weak formulation of the 2D single variable FEM model equation. So this is the model equation. So when we are developing the weak form of this model equation, we will be using one theorem for developing the boundary terms. So what would be the theorem? So A is gradient theorem, B is the divergence theorem, C is Stokes theorem, and D is the Green's theorem. So what is the answer for this question? Can you just take a guess?
So divergence theorem.
Yes. So divergence theorem. Yes, you are right. Answer is B. So can you tell what is the divergence theorem does basically? So
Uh,
mathematically,
relation between the
yes,
mathematically it is relation between surface and volume.
correct. So basically, volume integral you are basically converting into a surface integral, correct? So
Yes, sir.
when you have something, you have a divergence of a function. Let us say you are having, this is a del f. So yeah, if you are going to integrate it over the volume, so this is my element, and this is going to be the volume of the element, and this is going to be the surface. The surface are indicated by this gamma. So when I do that, so just a minute. So some function if I have means d omega. So this divergence of the function I am going to integrate across the volume. So when you are going, this will be equal to the surface integral of the function uh, something like that. So this function you are again integrating, we are multiplying with the unit the normal vector. So normal will be at every point, it will be normal to the point, and that we are multiplying with the function, and that we are integrating over the surface. So ds is nothing but, let us say this is a small length along the surface that you are going to integrate through this gamma. So this is what the divergence theorem states for us. So hence the answer is option B. So we'll see how we are going to develop the weak form. So because we have some question related to this also. So we'll go to the next question. So this is a subjective type of question. So we have some partial differential equation in some domain, and we have some condition on the boundary. So for this we are going to develop the weak form and the finite element model. That is a weak, essentially we are going to develop the weak form. So I will just go to the notes part. I'll open the notes. Go to one note. Okay. Give a new weak 5. This is week 5. Okay. So if I just repeat, I'll just look at the question. So minus del square u plus u is equal to 0. 0 and dou u by dou n plus beta u is equal to qn. So let us say this is my element, this is the domain, and this is the boundary. So now I am going to write model equation. So when I write the model equation, we will see that this particular thing is going to be a particular case of the model equation. So if I recall, minus dou by dou x of a11 dou u by dou x plus a12 dou u by dou y minus dou by dou y of a21 dou u by dou x is a22 dou u by dou y plus a00 u minus f is equal to 0. So if I compare this first and two, so let us write in the side what is del square u. So del square basically means dou square by dou x square plus dou square by dou y square. Okay, so which means I have minus dou square u by dou x square minus dou square u by dou y square plus cu is equal to 0. So if I compare both, so what is my a11, a12, a21, a22 and a00? Yes, I have 5. So if I compare with this, so there is no dou x dou y terms are there, all it's either x square or y square. So for that to happen, what will be my a12 and a21? What should the value be? So if I want to get this from here, I have to get here means, so can you guess? So a12 a21, because we do
Zero.
not have,
Zero.
yes, it should be, both should be 0, because we do not have any dou x dou y term, we have only dou x square and dou y square, and at the same time we do not have any constant, so it's just a simple u. So the constant value will be 1. If I see a11 and a22 should be equal to 1, and if I consider the coefficient of c, in both the cases, it's here it's a00 and here it's c. So here my a00 is going to be c. So this is my constant values. So what I am going to do is I'm going to solve the weak form of the model equation in general, and then I'm going to in the end I'm going to just substitute these constants, and then I will just get the equation for weak form of the equation for the question which we are trying to solve. So we'll try to solve that one by one, step by step. So let me once again write the model equation. Minus dou by dou x of a11 dou u by dou x plus a12 dou u by dou y minus dou by dou y of a21 dou u by dou x plus a22 dou u by dou y plus a00 u minus f, which is equal to 0. So this is my model equation. So first step is anyway discretization of the domain. Assume that we have already discretized the domain, and we are now going to solve the this equation for the particular element, this one. So this is my element and this is the domain. So which means here I am indicating my, I am going to solve this equation for my particular element, eth element, you can say. So to develop weak form, so what should we do to develop weak form? So we have this equation. So basically what we need to do is we have to multiply this entire equation by some weight function and integrate it over the domain and equal it to 0. So let us say that our w is the weight function. So which means let us say this is the whole thing. So I am going to entire equation I am going to integrate into w into minus dou by dou x of a11 dou u by dou x plus a12 dou u by dou y minus dou by dou y of a21 dou u by dou x plus a22 dou u by dou y plus a00 u minus f. I am going to integrate it over the element, and similarly d omega is equal to 0. So this is the weighted residual, you can say. So weighted residual means we are going to get the residual, we are going to multiply it with the weight and then integrate it over the domain and equal it to 0. So this is called a weighted residual integral. So what we are going to do is we are going to take this as f1 and this as f2. We are going to slightly shorten the equation for our convenience, and later we will substitute back the f1 and f2. So if I am going to do this, w into minus dou f1 by dou x minus dou f2 by dou y plus a00 u minus f d omega equal to 0. Okay. So I am going to basically split this integral now. So which for one case I am going to just retain minus of w times dou f1 by dou x plus dou f2 by dou y, or let us say I am going to I am going to write it w with the w for both the terms. D omega, then plus a00 uw d omega minus wf d omega is equal to 0. Okay, so just now that I remember, so in our case we see that for our particular equation we derive the constants, but we see that there is a u term but there is no f term in our term. So here we can say that f is equal to 0. That is also an additional term. So now coming back to the model equation, so I am going to split this I1, I2, I3. So I1 I am going to concentrate. I1 is equal to minus of W dou f1 by dou x plus W dou f2 by dou y into d omega. So for each term now we are going to use the integration by parts. So you can say that d by some dx of, let us say, uv is equal to u dv plus v du by dx. So with this means that u dv by dx is equal to d by dx of uv minus v du by dx. So this is the integration by parts, which means that we are just using the chain rule, and now we take the one side. I'll erase this. So W dou f1 by dou x is equal to dou by dou x of W f1 minus f1 dou W by dou x. Okay, this is, I hope there is no doubt in this. So just that I use the chain rule which I demonstrated previously, and I am using substituting it for this purpose. Again, W dou f2 by dou y is equal to dou by dou y of W f2 minus f2 dou W by dou y. So if I add both, I am essentially going to add everything. So I1 again. So this both, so I have a minus sign here. So if I add both, I am going to get dou by dou x of W f1 plus dou by dou y of W f2 minus f1 dou W by dou x minus f2 dou W by dou y. This entire thing d omega. So what I have done is I have individually added both the equations, so I get like this. So further split I am going to do, I am going to take the inside. So this minus sign I am going to take it inside, which means I am going to be f1 dou W by dou x plus f2 dou W by dou y minus this entire thing dou by dou x of W f1 plus dou by dou y of W f2. This entire thing I have to integrate for the domain. So once the minus sign I have taken inside, now I am going to again split this into two, f1 dou W by dou x plus f2 dou W by dou y into d omega minus dou by dou x of W f1 plus dou by dou y of W f2 into d omega. Okay, this term I can write it in this fashion. Delta of some WF. So what does this mean? This is means dou by dou x I cap plus dou by dou y j cap dot product with W f1 I cap plus W f2 j cap. So since it's a dot product, we can see that W f1, this will be dou by dou x of W f1. So which means I cap and I cap I am going to merge, and same thing j cap and j cap they will merge. This will be dou by dou y of W f2. So this is nothing but what we have already seen before. So we can rewrite this entire I1. So this was I1. So I1 I am going to rewrite like this: integral over domain f1 dou w by dou x plus f2 dou w by dou y d omega minus integral over the domain del dot wf d omega. So we saw that now we have to take use of the divergence theorem. So what is integral of del dot wf? So what is this integral? So can anybody tell? So I am going taking the gradient of the wf vector. So this is a volume integral. What I am going to get in the side?
Surface integral, sir.
Yes, surface integral. So that how I am going to get it? I am going to get it this way. So for surface integral, always remember we are going to do this circular symbol, because that means it is a surface integral. So surface integral across the boundary. So if you go up, I would have defined the element and boundary in this way. So my element is omega e and my boundary is gamma e. So this is going to be this same vector. I am going to multiply it with the unit normal, and this is going to be ds. So so this is going to be, so wf is wf1 I cap plus wf2 j cap. This I am going to dot product with, let us say, nx I cap plus ny j cap into ds. So this is going to be wf1 nx plus wf2 ny into ds. So now I am going to rewrite again I1. So what is I1? So this second term I am going to replace with the term which we got below. So it is going to be integrate our domain f1 dou w by dou x plus f2 dou w by dou y into d omega minus, this is going to be a surface integral, wf1 nx plus wf2 ny into ds. Okay, this is I1. So I1, I2, I3 is going to remain the same way. So we have just calculated I1. So I have already included the minus symbol. So I1 plus I2 plus I3 I am directly going to do. So I is equal to I1 plus I2 plus I3. So which is going to be f1 dou w by dou x plus f2 dou w by dou y to d omega minus surface integral w f1 nx plus w f2 ny into ds plus integral over the domain a00 uw d omega plus, so whether it's plus or minus, let me see. This is plus and this is minus, wf minus wf d omega is equal to 0. Entire I is equal to 0. So I am going to some terms I am going to retain in the left hand side, some terms I am going to retain in the right hand side. So I am going to do it like this: f1 dou w by dou x plus f2 dou w by dou y plus a00 uw into d omega is equal to integral wf d omega plus wf1 nx plus wf2 ny ds. So this is my weak form. So this is going to be related to the stiffness matrix, and this is going to be related to my force vector, and this is going to be my boundary terms. Okay, so recall what is F1 and F2. So our F1 was A11 dou u by dou x plus A12 dou u by dou y. F2 is equal to A21 dou u by dou x plus A22 dou u by dou y. So let us now start to substitute. So our A11 A equal to 1, A12 was 0, A21 again is 0, A22 is equal to 1, A00 is equal to C, F is equal to 0. So if we substitute everything here, so F1, my F1 will become simply dou u by dou x. This will vanish off. Again this will also vanish off. So F2 will become dou u by dou y. A00 is C, and this is also again is going to vanish off because my F is 0 in this particular case. So I substitute everything. F1 dou u by dou x, integral of dou u by dou x into dou w by dou x plus F2 dou u by dou y into dou w by dou y. So this is over the domain. Sorry, I have one more thing, plus A00 is going to be C, so which means CUW. So d omega is here going to be simply dx dy. So I replace d omega by dx dy, and in the right hand side I am going to have only this term. So integral over the boundary. So W F1 dou u by dou x into nx plus W dou u by dou y ny. So W F1 F2 W F1 nx plus W F2 ny. This whole thing multiply with ds. So this is my weak form. So in this weak form, if I substitute, let us say my u is equal to summation I is equal to 1 to n. So let us say j equal to 1 to n u j psi j. So what are u? U at jth node. This psi is nothing but interpolation function. And my w is going to be psi I. So this we have already seen in many cases. In the one dimension also we saw that our weighting function is nothing but the variation of the primary variable. So in this function, if we can satisfy, we can substitute like this. So dou u by dou x. So dou by dou x of summation uj psi j. Dou u by dou x, dou w by dou x, dou psi I, dou y. Okay, it's dou x only. Plus dou u by dou y into dou w by dou y. So dou by dou y of summation j is equal to 1 to n uj psi j into dou psi I by dou y plus c uw uj psi j psi I. This whole thing I am going to integrate across dx dy. This boundary term I am going to keep as it is. Let it be like this. So uj I can take common outside. So summation j equal to 1 to n uj into integral, or rather let us say I will put this in the right hand side. Integral dou psi I by dou x dou psi j by dou x plus dou psi I by dou y into dou psi j by dou y plus c psi I psi j into whole thing integral over dx dy over the domain. This whole thing summation j is equal to 1 to n uj. So this I can write it as kij uj. This kij is nothing but the stiffness matrix. What is kij? Integral over the element dou psi I by dou x into dou psi j by dou x plus dou psi I by dou y into dou psi j by dou y plus c psi I psi j dx dy. So this is the stiffness matrix. So we solve the weak form and we also develop the term for the stiffness matrix. So if you recall, from here we have come to here. So this is the so I will write kij here. Okay, I will erase. C psi I psi j, the whole thing I am going to integrate dx dy. So this is my kij. So this is the thing. So now we will go to the next question. Okay. So again we are considering the model equation. So assuming that a11, a12, a21, a22 and a0 are independent of u. If the weak form of the above equation can be expressed in the form b of w comma u is equal to L of w. So which of the following conditions is necessary for the term b of w comma u to be bilinear and symmetric? So we have again four options. Option A is our a00 should be 0. Option B is a11 is equal to a22. Option C is a21 is equal a12 is equal to a21. Option D all of the above. So can you guess the answer for this? So bilinear and symmetric. Okay. So we'll see this thing itself. So for this previous question,
last problem itself we are getting in previous problem itself we are getting bilinear and symmetric.
yes sir, yes, correct. We got the bilinear and symmetric. But do you think all should be satisfied, or should you think only one of the? So in our case we saw that Okay, all of the above. So in our case we saw that it was all of the above. Here we saw that all the above equations. So if we see the a values, so which means here my a00 is C. Is this so here in our case it is not necessarily 0. So here our a11 and a22 are equal. Again a12, a21 both are 0. So and here a00 is C. So which means in our last case, if you see here among the A, B, C, I can say that my B and C are satisfied, but A is not satisfied. But still I got a bilinear term. So do you agree?
Yes, sir. Yes, sir.
Yeah, we got a bilinear term. But so you can say that among these, uh, only one point you can say is important. So bilinear and symmetric. When is you expect the symmetric? So among B and C, which condition do you think needs to be satisfied?
C, sir. C.
Yes, C. Okay. Answer is yes. You are right. Answer is C. So last example itself we saw that a00 need not be 0 for the case to be bilinear. So option A is ruled out. So between B and C, we observe that C is the more important thing, because if only your a12 is equal to a21, both your terms, so this term, so when I evaluate this term and when I evaluate this term, so both will be uh, dou by dou x of a dou u by dou y, and this will be dou by dou y of a dou u by dou x. So if I replace, so both are you can say equivalent. So if I replace with w, if I multiply with w, and w and u I can interchange in this case. So if you see the here in this formulation, so I can take this formulation itself, right? So no need to go here. I will take here. So here we simplified based on our condition, right? So here if you have taken a11 and this to be as it is as a22, still you will see that you will get a bilinear term, bilinear and symmetric term you will able to get. So bilinear and symmetric in the term, so bilinear of w comma u. So which means if I replace u with w with u and u with w, I will still get the same term. So that is what I mean by bilinear and symmetric. So so this is the thing. So bilinear in the sense it will have term of both w and u in the first order, in the same equal order, and then if I replace w by u and u by w, I'm going to get the same term. That is what I mean by bilinear. Yeah. So answer is C. So any doubt in this? So shall I
No, sir. No,
go to
sir.
the
Essentially, we need condition C. Huh?
yes, correct.
Okay.
Condition C is the main condition.
A12 should be equal to A21. Okay, sir.
Correct. Okay. So we'll go to the next question. Okay. The question is which uh, uh, which of the following functions can be an interpolation function for 2D FEA model equation in the weak form? So we have four options. So first option is 2 plus x plus 3x square. So second option is 1 plus 3x plus 4y. Third option is 6 plus 3y. So fourth option is 3 plus 2x plus 5y minus xy plus 7x square plus y square. So can you guess what could be the answer?
Maybe I think B, sir. Answer B.
Okay. So here what I'm essentially I'm trying to ask is the polynomial should be complete. Okay. So if you see in this answer, if you check, yes, you are right, answer is B. If you see here, there is no y square or xy term, so this is incomplete. So here if you see both x and y are there, so it's a complete. So here x term is missing, so it is incomplete. But here if you see x square and y square, they are having the same coefficient, so they should have actually different coefficient. So again you can say that this is incomplete. So because of this you can say that answer is B. So B is eligible for being an interpolation function. Okay. So this is one question, ninth question we saw. So now we are going to solve a problem related to interpolation functions. For triangular elements, compute the interpolation function for the weak form of 2D FEA model equation. Okay, so I am going to again switch back to my notes. I am going to just note down the this thing. Okay. So now I am going to, this is my, just draw this line. So I have this x and y, have a triangle. So let me say this is x1 comma y1, this is okay, 2 is x2 comma y2 over here, and here is x3 comma y3. Okay, so what was this point? The first point was 2 comma 1, second point was 3 comma 4, third point was 5 comma 3. So which means my x1 is equal to 2, x2 is equal to 3, x3 is equal to 5, y1 is equal to 1, y2 is equal to 4, y3 is equal to 3. So this is my thing. So what I am going to do is I am going to try to solve the interpolation function. So here I can assume the interpolation function to be of this form: u is equal to u of x comma y, which is equal to c1 plus c2x plus c3y. So this is my interpolation function assumption. So I am going to substitute each point one by one at u is equal to sorry, at point 1 u1 is equal to c1 plus c2 x1 plus c3 y1. So let us solve for x1 y1 in general, and then we will try to substitute this later. So again if I do u2 c2 plus sorry is going to be c1 plus c2 x2 plus c3 y2. u3 is going to be c1 plus c2 x3 plus c3 y3. So this is point 1, this is point 2, this is point 3. So if I try to represent in matrix notation, u1 u2 u3, this is going to be 1 x1 y1, 1 x2 y2, 1 x3 y3 into c1 c2 c3. So we can say that this is my u in the element is equal to some A matrix into C. So my objective is to find out C. So how do I find out? my C is going to be A inverse of U. So let us so my A was 1 x1 x3 y1 y2 y3. So for a 3 cross 3 you can say that A inverse is equal to your adjoint matrix by your determinant. So what is adjoint? Adjoint matrix, let us say it's a okay, let us keep that way only. So what is adjoint? 1 1. So adjoint means for this first element I am going to just multiply this way, and my sign will be plus minus plus minus plus minus plus minus plus. So adjoint A11 it will be plus of this x2 y3 minus x3 y2. My adjoint A, the 1 2 will be this element. If I delete this row and this, it will be this one y3 minus of y3 minus y2. This is going to be y2 minus y3. So adjoint 1 3 going to be, if I exclude this first row and first row and third column, it is going to be x3 minus x2, which is going to be minus of x2 minus x3. Okay. So adjoint of 2 1. So it will be with a minus sign. So if I exclude this, it's going to be x1 y3 minus 3 y1. So this will be x3 y1 minus x1 y3. So adjoint of 2 2, it will come with a plus sign, and this I am going to include the, I am going to exclude the second row and second column, and what is remaining is y3 minus y1. So adjoint of 2 3, it will come with a minus sign. So I am going to exclude this third column and second row and third column. What will I get? x3 minus x1. Okay. So adjoint of 3 1, I am going to exclude the third row and first column. It's going to be x1 y, it's going to be x1 y2 minus x2 y1 with a plus symbol. So adjoint A of 3 2, this here I am going to exclude the third row and second column. It is going to be minus of y2 minus y1. So this is nothing but y1 minus y2. So adjoint A 3 3 is equal to, I am going to exclude the third row and third column. So it will be x2 minus x1 with a plus. So I am going to write this as minus of x1 minus x2. So these are the adjoints. So what is the determinant? So it will be 1 times of x2 y3 minus x3 y2 . So I am going to minus 1 times x1 y3 minus x3 y1 plus 1 times x1 y2 minus x2 y1. So which is equal to x2 y3 minus x3 y2 plus x3 y1 minus x1 y3 plus x1 y2 minus x2 y1. So this will be 2 times area of triangle. So area of a triangle with x1 x1 comma y1 x2 comma y2 x2 comma y3 is half of this determinant. So this determinant will be 2 times the area of triangle. Let us say this is some 2AE. Okay. So now I am going to write my adjoint matrix entirely. So here I am going to write a unit by element by element. First will be x2 y3 minus x3 y2. Then second row first will be x3 y1 minus x1 y3. So this will be, so 1 by sorry, this is only adjoint, so this one come. So again the third will be x1 y2 minus x2 y. So 1 2 was y2 minus y3 y3 minus y1 y1 minus y2. So this will be minus of x2 minus x3. I am correct? Yes, minus of x2 minus x3 minus of x3 minus x1 minus of x1 minus x2. So this was adjoint. So if I just, we are going to replace this by A inverse is equal to this adjoint by determinant. So this is my inverse. So I can express this as 1 by 2AE alpha 1 something like this. So let us say alpha 2 alpha 3 beta 1 beta 2 beta 3 gamma 1 gamma 2 gamma 3. So this is my A inverse. So if I want to generalize the alpha, beta and gamma, I can write it this way: alpha of I. So I varies from 1 to 3. So I can take any one value. So alpha is equal to xj yk minus xk yj. So how this j and k are going to come means, I am going to have 1 2 3 like this. Similarly my, okay, so if I is equal to 1, then my j will be 2, then my k will be 3. Or else if you take another case, so basically it's a permutation. So if I am going to take my I, then I am going to go this direction, I am going to fix this as j, and I am going to go this direction, I am going to fix this as k. So if I put alpha is equal to xj yk minus xk yj, so let us take alpha 3. So I is equal to 3. So this is my I. So next wall is going to be my way, and next this is going to be my k. So xj x1 yk y2 minus xk x2 y1. So this is my alpha. So whether we'll see whether it's the same. Yes, x1 y2 minus x2 y1. So like this way we are going to generalize. So similarly, this is my alpha 3. So for betas it's going to be this way: beta I is equal to x, sorry, not x, yj minus yk. Gamma I is equal to minus of xj minus xk. So this is my alpha, beta and gamma. So A inverse we just found out. So what we have to do? We have to multiply this A inverse with U to get the C matrix. So I'm going to do that. So C1, C2, C3 is equal to 1 by 2AE alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, gamma 1, gamma 2, gamma 3 into U1, U2, U3. So what is C1? 1 by 2AE alpha 1 U1 plus alpha 2 U2 plus alpha 3 U3. C2 is 1 by 2AE beta 1 U1 plus beta 2 U2 plus beta 3 U3. C3 is gamma 1 U1 plus gamma 2 U2 plus gamma 3 U3. So we have found out C1, C2, C3, but what is our objective? Our objective is to find the interpolation function. So U. So this one I can write it as summation I is equal to 1 to 3 uj psi j of x comma y. So now what is my u? C1 plus C2x plus C3y. So C1, what is my C1? 1 by 2AE into alpha 1 U1 plus alpha 2 U2 plus alpha 3 U3 plus C2 again 1 by 2AE beta 1 U1 plus beta 2 U2 plus beta 3 U3 into x plus 1 by 2AE into gamma 1 U1 plus gamma 2 U2 plus gamma 3 U3 into y. Okay, now this whole thing I can write it in this way. So some term into U1 plus some term into U2 plus some term into U3. So this will be my psi 1, psi 2, psi 3. So if I compare both, so if I collect all the coefficients of U1, that is going to be my psi 1. If I collect all the coefficients of U2, it's going to be my psi 2. If I collect all the coefficients of psi 3, it's going to be U3. So what is psi 1? So what is U1 from here? So 1 by 2 AE into alpha 1. Then from here 1 by 2 AE beta 1 and x from here. Then similarly 1 by 2 AE gamma 1 y. Okay. So this is my psi 1. So my psi 2 I can similarly write this. So alpha, beta, gamma 1, it's all going to change into 2. So I'll write it 1 by 2 AE alpha 2 plus 1 by 2 AE beta 2x plus 1 by 2 AE gamma 2 y. Psi 3 is going to be 1 by 2 AE alpha 3 plus 1 by 2 AE beta 3x plus 1 by 2 AE gamma 3 y. So essentially what is my psi? Psi general. So psi 1, psi 2, psi 3 we have calculated the interpolation functions. So these are the interpolation functions. So we have calculated the interpolation functions. So what we are essentially going to do, we have to go back, look at our x1, x2, x3. So our x1, x2, x3 was this one 2, 3, 5, 1, 4, 3. x1 is equal to 2, y1, y2, y3. So what is I1? So first we have to calculate alphas, alpha, beta and gamma. Yes, so what is alpha 1? Okay, before that we are going to simply calculate what is the area. 2AE is nothing but x2 y3 minus x3 y2 plus x3 y1 x1 y3 plus x1 y2 x2 y1. Correct? Where was the A formula? Yes, this one. So this will be equal to, what is x2? 3 times y3, 3 minus x3 y2, 5 times 4 plus x3 y1, 5 into 1 minus x1, 2 into y3, 3 plus x1 y2, 2 into 4 minus x2 y1, 3 into 1. So I'll just a minute, I'll just take my calculator. So this is going to be 9 minus 20 plus 5 minus 6 plus 8 minus 3. Is this correct? 2 comma 1, 3 comma 4, 5 comma 3. Okay. So what is area? 9 minus 20 plus 5 minus 6 plus 8 minus 3. So I am getting minus 7. Okay. Now what is alpha 1, beta 1, gamma 1? Okay. So alpha 1 is x2 y3 minus x3 y2. So this will be minus 11, beta 1, sorry, we will calculate alpha 1 by 1, then we will go for beta gamma. This is minus 1, 5. So beta 1 y2 minus y3. What is y2 minus y3? Y2 minus 4 minus 1, sorry, 4 minus 3, 1, y3 minus y1, 3 minus 1. Then beta 3 is y1 minus y2. Minus 3. Gamma 1 minus of x2 minus x3. 3 minus 5. This will be plus 2. Gamma 2 is equal to minus of x3 minus x1 minus of 5 minus 3. this will be, is it 5 minus 3? Sorry, it's 5 minus 2. Minus 3. Gamma 3 is equal to minus of x1 minus x2. Minus of x1. 2 minus 3. 1. So what is psi 1? 1 by 2ae alpha 1 plus beta 1 x plus gamma 1 y. So 1 by, what is 2ae? We just saw, no? Minus 7 it was, I think. Yes, minus 7 alpha 1 minus 11 beta 1 x plus gamma 1 y. 11 by 7 minus x by 7 minus 2y by 7. So psi 1 is equal to 1 by 7, 11 minus x minus 2y. So psi 2 is 1 by 2ae alpha 2 plus beta 2x plus gamma 2y. 1 by minus 7 into alpha 2 minus 1 plus beta 2x plus gamma 2y. What is gamma 2? Minus 3. So this will be 1 by 7 into 1 minus 2x plus 3y. Then psi 3, 1 by 2ae into alpha 3 plus beta 3x plus gamma 3y. 1 by minus 7 into alpha 3 5 minus 3 1. So this will be 1 by 7 into minus 5 plus 3x minus y. So this is psi 3, psi 1, psi 2 and psi 3. So we will verify. So what will be psi 1 at x1 comma y1? So can you guess what will be psi 1 at x1 comma y1? What should be ideally? So we have the property that psi will be psi 1 psi I of xj comma yj. So this will be nothing but delta ij. This will be 1 when I is equal to j, sorry, and 0 when I not equal to j. So this is a Kronecker delta function. So if you put x1 y1, whether you are getting 1, let us see. So what is x1? 2 comma 1. So put 2 and 1. So 1 by 7 into 11 minus 2 minus 2. So 11 minus 7, sorry, 11 minus 4 7, 7 by 7 is 1. So rest other, if you put, you should get 0. So if you put x2 comma y2, psi 1 of x2 comma y2, 1 by 7 into 11 minus, what is x2 comma y2? 3 comma 4. So 2 4 8, 8 minus 3 11, sorry, 8 plus 11, 11 minus 1, this is 0. Psi 1 of x3 comma y3. What is x3 comma y3?
5 comma 3.
Yes, 5 comma 3. Okay, so 11 minus 5 minus 2 into 3, this also 0, no? So 5 minus 6, so sorry, minus 5 minus 6 will be minus 11, minus 11 plus 11 0. So always, so you can check the for psi 2 and psi 3 also, this will be true. So we checked for psi 1. So these are the interpolation function for the triangular elements. So we got 3 interpolation functions corresponding to the 3 nodes of the triangle. So this is the one, this is the triangle. Okay, so we'll now go back to presentation. We have one last question actually. So here we have a rectangle, so we are going to compute the interpolation function for the rectangle also. So we'll now again go back to notes. So for rectangle, let me draw this thing. This is x, this is y. So rectangle, in this rectangle we see that the sides are parallel to the axis. So that is one advantage we have here.
Sir, what we are looking for in the previous problem, simply finding psi 1 at first node is 1,
Yes,
psi 2
actually
at
yes,
second node is 1, psi 3 at third node is 1, like
yeah, correct. So we have to compute the interpolation function. So if I want to conclude the answer, I just have to conclude what is psi 1, psi 2, psi 3. These are the interpolation functions, right?
yes, yes, sir.
So interpolation function will be in terms of x and y. So your psi 1 is
Psi 1, psi 2, psi 2 for verifying we are doing so, right?
yeah. So this is one verification we are doing, whether we got the our value of psi 1, psi 2, psi 3 are correct or not.
Okay, sir.
So we have the psi 1 as a function of, so if I slightly erase these things, so my interpolation functions are all functions of x comma y, correct? So psi 1 of x comma y, psi 2 of x comma y, psi 3 of x comma y. So these are what we are asked to find, and we got the expressions 1 by 7, 11 minus x minus 2y, and psi 2 was 1 minus 2x plus 3y. This was 1 by 7 into minus 5 plus 3x minus y. So this is the final result. So whether what we got is correct or not, for the verification, we can say that my psi I of xj comma yj should be delta ij, which is equal to 1 when I equal to j and 0 when I not equal to j. So which means this value will be 1 for 1 and 0 for 2 and 3. Same thing, this will be 1 for 2 and 0 for 1 and 3. See, psi 2 means it will be 1 at x2 comma y2. So you simply substitute 3 comma 4 here. So what are you getting? So this will be 3 comma 3 into 4 12 minus 2 into 3 6 plus 1. So 12 minus 6 6 plus 1 7, 7 by 7 1. So are you able to understand?
Understood, sir. Understood, sir. Understood.
Yeah.
Yeah.
Okay. So this will be same for 1, it will be for the third point, and for first and second point this value will be 0. So similarly, now one more question we are going to do. So we have, this is my 1, this is my 2, this is my 3 and this is my 4. I want to find psi 1, psi 2, psi 3 and psi 4. So again we are going to do the similar procedure. So I am drawing the rectangle. Oh, sorry. already I have drawn here. So I will just note down the thing. This 1 comma 1, this 4.5 comma 1, this is 4.5 comma 3.5, and this is 1 comma 3.5. Okay, so this is my thing. So now for my rectangle, 4 noded rectangle, I can assume the function u to be like this: c1 plus c2x plus c3y plus c4xy. So earlier our triangle was called linear triangle. Since it has only, if you see the triangle, the approximation, it was c1 plus c2x plus c3y. So this is called as linear. So if I go here, this is called bilinear. So this is the difference between triangle and rectangle. In triangle you have only three nodes, so you have 3 unknowns. Here you have 4 nodes, so you have 4 unknowns: c1, c2, c3, c4. Same way we are going to find out, like the last problem, what is c1, what is c2, what is c3, what is c4, and then we are going to find what is psi1, psi2, psi3 and psi4. So this will be j equal to 1 to 4 uj psi j. Okay, so I am going to slightly rewrite. I am going to do in the x bar y bar. So what is x bar y bar means? I am going to transfer this into these coordinates. So it means that I am going to shift the rectangle to the origin. This will make my calculations easier. So 0 comma 0. So accordingly, this length will be 3.5, means this will be 3.5 comma 0. This will be 3.5 comma 2.5. This will be 0 comma 2.5. Okay, so this is going to be A and this is going to be B. So when you have a rectangle like this, since the axes are parallel to both the x direction and y direction in our case, so it is easier to shift to the origin, and we are writing means we are shifting the origin to the first point. So I am going to write in this fashion: c1 plus c2 x bar plus c3 y bar plus c4 x bar y bar. So later x, so in our case what is x? X bar is equal to x minus 1 and y bar is equal to y minus 1. So it means at 1 my x bar is 0, at 1 comma 1 we are shifting to the origin, which means my x and y are shifted by one unit each. So this is the conversion unit. We will now solve in this format, and later we will substitute the x bar and y bar. So that will make our calculation easier, because we have 0 terms. So that is the thing. So I am going to solve for a general triangle actually. So general triangle, in the sense, I am going to do like this: 0 comma 0. My length is going to be a, so which means this will be a comma 0, this will going to be a comma b, and this is going to be 0 comma b. My breadth is going to be b, length is going to be a. Okay, so what is u1? U at x1 comma y1 x bar. So again this is going to be my 1 2 3 4. So first point I am going to substitute 0 0, so it's going to be c1 plus c2 times of 0 plus c3 times of 0 plus c4 times of 0 0. So this is just going to be c1. So since the choice of the coordinates, I have shifted the origin. Now it is made by calculation much more simple. So that is why I do this. Later when we have developed all the interpolation functions, we can simply substitute x bar and y bar with x minus 1 and y minus 1. So that's the thing. So u2 is equal to u of x2 comma y2. So x2 comma y2 is, my x2 is going to be a, and y2 going to be 0. So C1 plus C2a plus C3 into 0 plus C4 into a into 0. If you see the difference between the last problem and this problem, the last problem we kept everything in the general term, in general coordinates as x1 y1, x2 y2 and x3 y3. But here, since there are 4 unknowns, it will be more tough to solve. 4 cross 4 matrix, it will be difficult to invert. So I am going to for that alone I simplified this. So this will going to be C1 plus C2a u2. This is my first equation, this is my second equation. So third, u3 is equal to u of x3 bar comma y3 bar. So this is going to be a and b. So this will be C1 plus C2a plus C3b plus C4ab. This is my third equation. So fourth equation, u4 is equal to u of x4 bar comma y4 bar. So that is 0 comma b. So C1 plus C2 times 0 plus C3 times b plus C4 times 0 and b. So this will be C1 plus C3b. So this is my fourth equation, u4. So from this it is easy to solve. I already have one equation. My C1 is nothing but u1. If I substitute same thing here in the second equation, u2 is equal to, instead of C1 I am going to put u1 plus C2 times a. So what is C2? u2 minus u1 by a. So see how simple this is turning out to be. Instead of solving a matrix and inverting it and all, we are directly now getting C1 and C2. That is because of the type of the element we have chosen and the type of the coordinates we have chosen. So since there are 0, it has made our calculations much simpler. So let us put in u4. The C1 I already determined as u1 plus C3 to b. So this implies C3 is equal to u4 minus u1 by b. This is another thing. So all these three I am going to substitute in the third equation. So third equation was u3 is equal to C1 C2x bar plus C3y bar plus C4, sorry, not this, I have to take this equation, this one, C1 plus C2a plus C3b plus C4ab. Now substituting everything, C1 is u1, C2 is nothing but u2 minus u1 by a, C3 again u4 minus u1 by b, C4 is unknown. So u3 is equal to, this a cancel, b cancel, u1 plus u2 minus u1 plus u4 minus u1 plus C4 ab. So this one cancel. So it is going to be u2 u4 minus u1 plus C4 ab. So C4 ab is equal to u1 minus u2, this I am taking this side, plus u3 minus u4, correct, because I am all taking the C4 ab I am retaining here, I am all the other I am taking to this side. So it becomes like this. So C4 is equal to u1 minus u2 plus u3 minus u4 by ab. I have got all the constants C1, C2, C3, C4. Now simply I have to substitute in the main equation, which is u. u of x comma y, x bar comma y bar is equal to c1 plus c2 x bar plus c3 y bar plus c4 x bar y bar. So c1 was u1, c2 was u2 minus u1 by a, c3 was u4 minus u1 by b, c4 was u1 minus u2 plus u3 minus u4 by ab into x bar y bar. So this is going to be summation of I equal to 1 to 4 uj psi j, which is me u1 psi 1 plus u2 psi 2 plus u3 psi 3 plus u4 psi 4. So if I compare these two equations, whatever is the coefficient of u1 is going to be my psi 1. So what is the psi 1? So here we have 1, then here you have minus x bar by a, then from here you have minus y bar by b, and from here you have plus x bar y bar by ab. So if I take like this 1 minus x bar by a, then y bar by b, if I take common 1 minus x bar by a, finally one minus x bar by a into 1 minus y bar by b. So I take 1 minus x bar by a is common, so if I take it common, 1 minus y bar by b will be remaining. So what is psi 2? I collect the u2 coefficients. What are the coefficients of u2? 1 x bar by a here and here. So we have x bar by b, then minus x bar y bar by ab. So which means x bar by a into 1 minus y bar by b. I'll write in the next line. X bar by a into 1 minus y bar by b. Okay. So what is psi 3? I am going to collect the coefficients of u3. What are the coefficients of u3? I think there is only one place is there. So x bar y bar by ab. Simple. Now what is psi 4? u4, where are u4? I think here one is there, y bar by b is there, and then minus x bar y bar by ab. So if I take y bar by b common, 1 minus x bar by a. So we have got psi 1, psi 2, psi 3, psi 4. Either you can solve, so what was our x bar? So this was our x.
X minus 1.
Yeah. X bar is x minus 1, y bar is y minus 1. So you can simply substitute this x minus 1 and you can again rewrite psi in terms of x and y. Psi 1 is, so just in terms of x and y, if I want to get, I can simply substitute this 1 minus x bar by a. And what was our value of a and b? So A was I think 3.5 and B was 2.5 I think. Yes. So this is A 3.5 and B 2.5. Or you can just simply leave it in x bar y bar and simply substitute the corresponding values. That is also fine. Anyway, we'll try to write it in terms of x and y itself. Psi 1 is equal to 1 minus x minus 1 by 2.5, 1 minus y minus 1 by 2. Okay, this will be 3.5. Psi 2 is x minus 1 by 3.5 into 1 minus y minus 1 by 2.5. Is that correct? Yes. Psi 3 will be x minus 1 by 3.5 into y minus 1 by 2.5. Psi 4 is equal to y minus 1 by 2.5 into 1 minus x minus 1 by 3.5. So these are my interpolation functions. This is terms of x and y. So we will go back to the presentation. Here I will just write in terms of x bar and y bar for simplicity. Okay. So here I put in x bar y bar. Okay. Here I replace the AB. I will put 3.5 2.5 directly. Okay, again now we have got the function, but how will you verify? So if I put 0 comma 0, I get the value of 1. So this will be 1 at 1 at 2 3 4. So at 2 3 4, if you put, it will become, you put x is equal to 3.5, 3.5 minus by 3.5, 1 minus 1 0, so it will become 0. In all other points it will be 0. If you can simply verify by substituting the points. And remember, while substituting, if you are substituting in x bar y bar, you have to substitute the corresponding x bar y bar values, and if you are going for the xy coordinate, you have to substitute the xy coordinates. So this will be 0 at 2 3 and 4. This will be 1 at 2 and 0 at 1 3 and 4. So this will be 1 at 3 and it will be 0 at 1 2 and 4. Sorry. This will be 1 at 4, 0 at 1 2 and 3. So you can simply substitute and see. So here finally we found out for the rectangular element. Here we have to ensure that the sides are parallel to the xy coordinates. So for this case also we found out what are the interpolation functions. So with this we close this session. So any doubts in the questions we discussed today? So we'll just simply recap what all we discussed from the first. So totally 11 questions we discussed. First we saw about what is the computational domain error. The second we saw about the type of during discretization always use small element size at higher areas of high gradient. The next one was transition elements. We have to remember that it is mainly used to connect two elements of different order. That is a lower order element to higher order element is a transition element. So this here also there is a transition taking place, but these are regular elements. These are regular triangular element, regular linear triangle elements. So these are not transition elements. Transition elements means it's a order difference. So different order. So this remember. So another is we saw that the transition from lower element density to higher element density must be gradual, and transition elements should be placed at areas away from the critical region, because there will be stress variation associated with transition elements, and that stress variation should not interfere with the critical region. So that we saw. So this was regarding the discretization. Then we saw for Poisson's ratio what is the relation for A11, A12, A21 and A00. So this is one question. The next question was we saw the divergence, about the divergence theorem. Next thing is we apply the divergence theorem, we calculated the weak form and the finite element model, that is stiffness matrix alone we calculated. The next is for the BWB term to be bilinear, this is the necessary, this is the necessary condition, all others are not necessary. So this is for 8th question. 9th question we saw that the polynomial should be complete in order to be used as an interpolation function, and it should not it should be linearly independent. Here x square and y square have the same term, so they are not linearly independent. So that is one thing. And question 10 we saw the interpolation function for triangular elements. Question 11 we saw the interpolation function for the rectangular element. So in these questions any doubt, or is everything clear till what we discussed?
Clear, sir. But
Yes.
one doubt, sir. The final exam descriptive question also may come, or only objective, sir?
Sometimes you may get some descriptive question where you have to enter the numerical answer. So for example, you might have to enter, suppose they will ask some value, so you should enter whether for 40, 50, like that you have to enter. Only like that you will get. Yeah.
So now derivation and all will not count.
No, derivation is not there. That is why I did just for the concept wise, that's all.
Okay.
Okay, so if there are no doubts, shall we close the session for today?
Yes, sir.
Okay, so we will meet. Okay, so we'll meet next week, same time, 6 to 8. So for
Sir,
that will
what
be
is
the
the pattern? Can you please tell, sir? Sorry for the cross. What is,
yeah.
how many marks? 100 marks, sir? Question.
Question, yes, it will be 100 marks, 3
Paper,
hours.
exam. 3 hours.
Yes,
And what is
yes.
the pattern? Small answer questions like that, please. Could you please guide us?
Actually, I will try to speak with sir, because I am also I'm not sure. So once
Okay,
I get,
multiple choice, descriptive, and small answer question, big answer question like that. No.
yes, you have some multiple choice question, and you will have some like, as I told, some numericals will be there where you have to just enter the value.
I got it. Just now I heard it. You told us that descriptive.
Yes,
But
yes,
okay,
yes, descriptive,
what
yes.
I'm thinking is like essay questions. I have written on some PhD paper recently coursework we have written. All 20
Okay.
marks, 520s, 10 marks also
Ah.
there. In
Ah.
MTech, what they are given 2 marks questions 5 and 5,
Ah.
12, 60. 60 plus 20, 80. Internals
Ah. Yes,
20.
yes. Okay, okay.
Like that, or multiple choice
It
50%. or 50% like this? No, that's
Ah, it
why
will be
I
more
think
or less.
I got a mail exam pattern something. Okay,
Okay.
I'll check it. I'll check
Yeah,
it
yeah.
there.
Please
Okay,
check. Yeah. Okay. So,
thank you.
shall we close the session for today?
Sure, sir. Thank you so much.
Okay. Okay.
Thank you so much.
Yeah.
Okay, sir.
Thank you.
Thank you, sir. Thank you, sir.
Okay.